Hello. Last one in my little series on log questions in the MEI C2 syllabus. Here we're looking at log evaluation and simplification questions, and I've put 3 out on the screen because they're so short, and it's just worth having a look through them. And I've tried to put them in an order of complexity, but I'll do them in a slightly different listing. So let's start off with the most basic one, which will go on in green. 6-1 on June 2007. Have a look at that. 1 point each. Write down the values of log base A of 1 and log base A of A. Okay, these should be absolutely fundamentals. That the log base A of 1 is 0. And remember, why is that the case? Because the question reading it, what power or do we have to put on A to get the value 1? Answer 0, because A to the 0 equals 1. Okay, and now let's have a look at the second one. These are the absolute bankers that you should have written down and programmed in your head. And the second one, what is the log base A of A? The answer, again reading it as the inverse of a power. What power do we have to raise A to get the total value of A? Answer 1, because A to the 1 equals A. There we go. So we can see quite quickly there's a point each for those. Now you should have those in your head and programmed in. You'll see in June 2006 they did a very similar question. They asked the first question again. So they've got log A of A, it's going to be 1. And then they asked us for the log A of A cubed. Now using the power law of logs, we know that that is 3 times log A of A, because we just moved the power to the outside. So the log of x to the n equals n times the log of x. And here we have log A of A again is going to be 1. 3 times 1 equals 3. So that's pretty straightforward. And that's the first group of questions we're going to get, where they're just going to ask you to evaluate it, and all our logs will drop out of the equation. Let's have a look at the second type of question we're going to see, and these are the blue. I'm going to pick out a blue question here. This type of question here, where it asks us to calculate, express the left-hand side there expression as a multiple of log A. So we know our answer is going to be in the form log A. So let's just quickly do that evaluation here. I'm just going to extend the page so we've got it to hand. So log A x to the n plus log A 1 over x. Got to get that in form of log A x, log base A of x. So what we're going to use, we're going to use our power laws. Well, the left hand one is immediately ready for that, because that's just going to become n times log A to the x. How about that? So we just move the n to the front as we do in the power law. Now what we're going to do with this second one, well, that's actually log of A of, let's reorganize that into a power arrangement. So 1 over x is x to the minus 1. Is that useful? We could go that way, and therefore we're going to have n log A minus 1, or log A, because it's minus 1 times there, A to the x. There we go. So n was 4. Apologies, I've done that wrong. So therefore we're going to have 3 log A to the x. There's that route through it. We could also have done that using one other way side. We could have taken our log A to the 1 over x, and we could have used our division law, in which case we'd have had log A to the 1 minus log A to the x, because effectively our x value in the formula would be, let's put that in here, would have been the 1, and our y value would have been the x. Okay, and the log of to the power a of 1 is 0. So that's just going to be log a of x. So we could have got to that point, couldn't we? And that brought us to the same place. But in effect, what we're doing here is just collecting, is converting them all by taking the powers out of the brackets and pulling them together. And then we are just collecting up our terms, and we end up with a form like that. Okay, let's have a look at the other type of question we've got here. This one on the 6.2, which is quite a tough one, and we're going to have a look at this one here over 10.2 as well. And here we're starting off with an addition or subtraction, and our answer is just a single figure, single value. So we've got to reorganize by effectively combining the terms rather than separating them out. So let's have a look at that top one first. Let's do that one. 10.2. Here we've got log 10b plus log 10c equals 3. There we go. That's fairly straightforward. So the first thing we're going to do is group up the left-hand side using the addition law. So that's going to be log b times c equals 3. Got two ways. We can just power this up now if we know what we're doing. So if we power that up to 10, that would show us which is the inverse of logging. That would show us the b to the c equals 10 to the 3. There's our 1,000. And they were interested here in us calculating b in terms of c. Let's just check that out. Make sure I got that right. Find b in terms of c, therefore b equals 1,000 over c. So that was pretty straightforward what we were doing there, and it was a one step. So let's have a look at this one and final one up here, which is quite a nasty one. So we've got to get log x to the 10. Let's do that. I'm going to do it in yellow actually here. Log x to the 10, and then we've got a minus another log. So let's combine those using our power laws. So using our division law of logs. So here we go. Log the base x to the 10. That was our first part, wasn't it? Base A. So there's our value. And we've got that in two parts, and we really don't want to have it in two parts. How do we combine that? Well, we can use our division law. So therefore we've got log to the base A, it should be. What have we got as our value of x in our law? Well, that's going to be our x to the 10. And because it's a minus, we've got our x over x cubed over 4 there. But it wasn't just a single minus, it was a minus 2. So minus 2 would give us a power. So you can see how we did that in steps. We worked out what our values were. We could have done it in 2 steps. Let's do it in 2 steps just in case, so you're all comfortable with that. X to the 10 minus the log of. We could have done that power bit first by moving the 2 inside. Are you okay with that? We just did the power inside, and so we did it in 2 steps. Now we're going to combine the 2, put them back inside. So there's our x to the 10 on the top. There's our x cubed over 4 all squared, which we know we can quite simply reorganize here. Let's start by expanding out all these brackets. We've got x to the 10 on the top. We've got x to the 6 underneath, and we had our divide by 4 squared, which is the same as divide by 4 squared. So we move that to the top, we move that to the top, and we got 4 squared. There we go. So what have we got now? We've got log a we got 4 squared, and we've got x to the 4, and they wanted us to get it into a final form of they wanted to take a 4 out the front, and they in the version we're working towards. Let's just check that. Back up the top, it's got a 4 out the front. So beginning with the end in mind now, we now need to start moving our x to the 4. To get a 4 out the front, we need to have x to the 4, and we need to do something here to this 4 squared, which is to say as 2 to the 4. We could have done it, if you want to do it slightly longer way, we could have said our 4 squared equals 4 squared to the half times 2. We can change the order of all that, can't we? So we can put, because we know that that's 2 times the half times 2. We agreed on that. So we can change the order and do 4 to the half times 2 times 2. And 4 to the half here is 2. And 2 times 2 is 4. So that could give us the same place. We can quickly rewrite that as 2 times x there to the power 4, which equals 4 times, using the power law, 2 to the x. Yeah, so we proved that whole thing, therefore we proved that the equals 4 log 2 to the x. There we go. So that's probably the quickest way to do those two types, and it's just seeing which way you want to go. Okay, as ever, here's my little summary of the topic. Top half here is information you should have off in your memory, that log the base a of 1 is always 0, because a to the 0 is 1, and log of a to the base a is 1 because a to the 1 equals a. Then we've got our 3 power laws there, our 3 log laws. Log a, x plus log y equals log x times y. Log x minus log y equals log x over y, and n times log x is the same as log x to the power n. And then a couple of quick hints. If they start by giving a single combined log, I'll look to split it up and break it down using the above laws until it simplifies. And if you're starting with a log plus or minus another log, look to combine them using the laws and then cancel stuff out inside the bracket. So best of luck with that.